Welcome to part 4 of the analog monitor project with Earth People Technology and the Arduino Uno. So we have so far in the previous sections written all the code for the Arduino, written all the code for the EPT-570 board, and written all the C# code. Everything's compiled, downloaded, and ready to go. So now what we want to do is assemble all the hardware and run the project, test it out, and show what this baby can do. Okay, so let's get started with the hardware.
To start with, we need to connect up the Earth People Technology board to the Arduino Uno board. This is quite simple, as the Earth People Technology EPT-570-AP board has the requisite plug-in connectors for the Arduino Uno. Just connect it up as shown in the video, like that. Snaps in. Next, connect up the USB Type B cable, and then our USB Type B Mini B to the Earth People Technology mini module, like thusly. Make the connections to the PC into two available USB slots. For connections to the EPT-570-AP board, I'm going to use a typical 10-pin Samtec male header that will plug in directly to the power connector of the Arduino Uno. Next, I used a 6-pin Samtec male header. I went to the soldering iron and attached 6 pigtails onto the Samtec header. This will allow all of my alligator clips to attach to the analog input connector without bumping up into each other. To connect them, just plug them straight into the analog connector, like that. So first, connect up the ground wire to pin 7 of the power connector. Make sure you get a good grip in there. Now I'm going to connect up all of the power supplies to available pins. So what we're looking at now is the 6 power supplies. As you can see, we have power supply number 1, number 2, 3, 4. Pan down. And number 5 and number 6. Next, I'll connect up the individual power supplies up to the analog inputs of the Arduino Uno. So I'll start with number 1. Just connect them like this. Then the number 2 supply. We'll connect up the number 2 pin. Number 3 is connected. And number 4. Number 5. And then the number 6 pin. Now at this point, it's all connected and ready to go, and we're plugged into the PC.
So now we're ready to test out the analog monitor project. We've got the hardware connected. We've got the CPLD code written and programmed into the CPLD. We've got the Arduino code written, compiled and programmed into its flash. And we've also got our C# project ready to go with a executable. So if you go to the EPT Analog Monitor Project CD, locate the project's active host 64-bit folder. Underneath there, there's a folder with the BIN name on it. Just click on that folder, and there's already a pre-compiled version of the EPT Analog Monitor executable, active host 64 DLL, and the FTD2XX64.dll. So the EPT Analog Monitor executable is going to use both of these libraries, these DLLs, to bring up the window. So double click on the executable, and a little analog monitor window will come up, and click on the drop down box, and you'll see that the code has already gone out and scanned the registry for any EPT device that are out there, and of course we found the EPT USB device, so click that and make sure it's selected, then go to the open button, click open. You'll see the labeled device connected come up. It lets you know that everything has been selected correctly. Now go down to the start button, click the start. You'll notice that all 6 of the analog monitor text boxes have been populated with zeros. This is because the power supplies are turned off at this point. It should be giving a nice perfect 0, which would give us 0 counts as they go through the ADCs on the Arduino. And so I'm going to turn on power supply number 1. That it's a dual power supply, so it's going to bring up both monitor 1 and monitor 2 text boxes. Do the same thing to the second power supply, which gives me monitor 3 and 4, and the third power supply, which is monitor 5 and 6 text boxes. Okay, so now we can see that all 6 monitor text boxes have ADC counts coming from it. So now, right now, the Arduino code is cycling through its loop. It's sampling the analog channel 0, then it puts the 8 bits on port D, puts the top 2 bits on port B, and then sets the address and write enable, and cycles through each channel. The result is sent to the CPLD. The CPLD repackages it into 2 byte chunks and sends it to the analog monitor window. Analog monitor window packages each sample to the 6 monitor text boxes that we see on the window here. So now let's set the scale factor. Now to do this, we need to calculate the result of the number of bits, which is going to be binary math 2 to the 10 bits, because it's a 10-bit ADC. So we take 2 to the 10th, that's 1024. So quickly, if we just look at the text boxes, you'll see that we're seeing about 710, 720 counts in each monitor window. That's about 70% of the full number of counts. So it's about 3.5 volts. So I'm going to turn it up a little bit. I'll turn it up to 5 volts. You see that was 1023 counts we saw there. So what we're seeing is the number of ADC counts, and we need to convert this to a real-world voltage. So that is the full-scale deflection, which is 5 volts, divided by the total number of counts, which is 1024. And then we'll take that scale factor and multiply it by the counts that we see in each text box, and that will provide us with the real voltage that that we're actually putting into each ADC channel. So let's bring up the calculator, and 1024, let's do 1 over that, multiply by 5 volts, and that gives us 0.00488. So what that means is that's 4.88 millivolts per count. So if we're seeing 1023 counts on the text box multiplied by 4.83, that'll be around 5 volts. So our code is already in the analog monitor box. So just hit the scale factor button, and you'll see the WinForm expand, and it will populate all these labels: scale factor 1, 2, 3, 4, 5, and then 6 scale factor windows. So to change the scale factor, just type in the value in, so it's 00488, and because we have set up a key press event, whenever you press a key, that scale factor is recorded in the set scale factor menu.cs code, and is immediately sent to that scale factor value, which is immediately multiplied by the resulting counts from the sample from the Arduino channel, and then result is displayed in the monitor text box window. So do that for each window. Just type in 0488. And again, the key press event takes over, and you'll see the scale factor immediately kick on. And so we're seeing about 3.5 volts for each of the power supplies. That's because I set it to the 3.5 volts for each of the 6 analog inputs. So let's turn down the voltage on power supply number 1. You'll look at the monitor 1 box. It's decreasing, going down by probably 10 millivolt steps there. We can see this. We'll go on 0 and turn it all the way back up to 4.9 volts. Since I think our scale factor is just a little bit off in our calculation. So we'll turn it back down to 3.5. So next, let's do power supply number 2, all the way down to 0, back up to around 2.7. Now let's try.
Choose number 4 as well. I can dial it down. Increments
5 millivolts, and this is because of
the power supply. It can only dial up at a certain resolution.
Okay, so now we'll adjust number 5 down to 0 and back up to 3, and number 6 down to 0 and back up to 2 volts, 2.5 volts. So what I'm trying to show you here is that each of the 6 monitor text boxes is completely independent of each other, and what we're doing here is sampling each analog input, converting it to digital, transmitting it to the PC, and displaying it to the PC in real time. There is no lag from when I'm adjusting the voltage to when I'm displaying it on the screen. So we have completely created an extremely fast analog monitor using the Arduino Uno and the EPT-570. So thanks for tuning in.